Hi, I'm Priyanka Bagde. In this video series, I introduce how to implement custom layers for your custom model with the Intel distribution of OpenVINO toolkit to achieve accelerated performance. First, let's briefly discuss the Intel distribution of OpenVINO toolkit. It is an inference tool to optimize the execution of your deep learning models on Intel hardware. It contains tools for deep learning inference as well as traditional computer vision. The deep learning deployment tool contains a model optimizer and an inference engine. The MO takes the pre-trained model from different frameworks such as TensorFlow, MXNet, ONNX, or Caffe, then optimizes and converts it to the intermediate representation format. The IE takes the IR formatted pre-trained model and loads it to the user-defined hardware for inference. The inference engine loads different plugins for different hardware. During the model conversion, MO goes through the list of supported operations. If the certain function or operation is not supported, MO will spit out the error and declare the unsupported operation as the custom layer. That means you need to define the custom layer into the MO. To see the framework layers that are supported by the model optimizer, refer to the supported frameworks layers which can be found in the links. The same logic applies for the inference engine as well. The IE loads the layers from the input model IR files into the specified device plugin, which will search a list of known layer implementations for the device. If your topology contains layers that are not in the list of known layers for the device, the inference engine considers the layer to be unsupported and reports an error. To see the layers that are supported by each device plugin for the IE, refer to the supported devices documentation in the links. If your model has a custom layer, you need to make changes at the MO as well as at the IE. At the MO level, you will declare the custom layer and its attributes and parameters. At the IE level, you will implement the logic for the custom layer. At MO, you need to add two files in Python. The first one is the custom layer extractor to identify the custom layer operation and extract parameters for each instance of the custom layer. The second file is the custom layer operation. It specifies the attributes that are supported by the custom layer and compute the output shape for each instance of the custom layer from its parameters. At the inference engine level, each device plugin includes a library of optimized implementations to execute known layer operations, which must be extended to execute a custom layer. For example, when adding a custom layer for the CPU, the programming language will be C++, and the extension is compiled to give a .dll or .so file. For the integrated GPU, the extension is written in OpenCL and the files for the custom operations will be in .cl and .xml format. Developers will only need to add specific functionality details in these templates. These files already contain required constructors and default libraries. For the extension generator tool, declaring a custom operation in the MO is referred to an extension. An implementation of the operation at the CPU is referred to a custom layer. At the GPU, it is referred to its kernel. The terminology is different, however, they all refer to the custom operation. In the next video, I cover how to implement custom layers at the model optimizer level. To download the Intel distribution of OpenVINO toolkit, follow the links. Thanks for watching, and I will see you next time.
Hey everyone, thanks for watching this video. If you liked it and haven't seen any of our other videos, subscribe to the Intel Software YouTube channel. You can also connect with other developers and enthusiasts in the comments, and we'll see you all next time.